Assalamualaikum. Okay, hi class. Today I would like to continue our lesson about numerical methods in chapter 7.4 is about solving eigenvalue and eigenvector using inverse power method. Okay, in the previous class we already learned about how to solve the eigenvalue and eigenvector using characteristic equation and also by using power method in order to get the highest or the largest eigenvalue. But now by using the inverse power method in order to get the smallest eigenvalue, which is denoted as lambda n, where the eigenvalue 1 is bigger than the others. Okay, and its corresponding eigenvector denotes as Vn can be obtained by inverse power method. To implement the inverse power method, a system of here, okay, where the A matrix A, okay, multiplied by eigenvector minus eigenvalue multiplied by identity matrix I, and then multiplied by eigenvector is equal to 0. And then it can be modified by multiplying the matrix A inverse, okay, inverse matrix A. Okay, so in this case the difference between the previous topic is by inverse matrix. Okay, we multiply the inverse A matrix. Okay, so this we multiply the matrix A multiplied by inverse matrix A, and then we multiply by the vector, eigenvector, and so on. So hence the eigenvalue can be calculated from the eigenvector in an iterative manner with this. Okay, so the difference is only this. Okay, the previous one we are using the original given, okay, matrix A. But now we have to process from matrix A, original from matrix A to matrix inverse matrix. Okay, that's it. The rest is same. The process is same as compared to the previous lectures. So this iteration requires an initial eigenvector V0. Okay, we have to know the initial eigenvector denotes as a V0 and iterate until certain condition. Okay, in this case the question should ask you to iterate until a certain amount of error, let's say 0.05. Okay, and then the smallest eigenvalue is given by lambda is equal to 1 over lambda k plus 1. This is the smallest eigenvalue. Okay, so you have to use this kind of formula in order to identify the smallest eigenvalue. Okay, so in engineering inverse power method is named as a standard matrix iteration method. This is due to inverse power method gives the lowest eigenvalue, which is the standard information in vibration. So we proceed on example 7.4. Okay, let's say give the given matrix A is like this. Okay, 4 1 2 1 0 1 and 2 1 4. Okay, and you have to process this matrix A into the inverse matrix. Okay, find the smallest eigenvalue and its corresponding eigenvector using inverse power method, and take the initial eigenvector as a 1 1 0 transpose to be like this 1 1 0, and iterate until 0.005. Okay class, first we have to you have to inverse the matrix A. Okay, in this case automatically get this number. So how we are going to get this number is, okay, you can I will put the link in the subscription, so so you can follow lah. Okay, this is the link of how you are going to get inverse matrix by using calculator, but in this case the calculator model is Canon strict. Okay, you can just try to identify how to get inverse matrix by using calculator. If your calculator model is different from this type of kind of video, and then you might check or get from other sources of video lah in YouTube channel. Okay, and then let's say we already get inverse matrix A, and then what we are going to do is same as the previous class, which this is the inverse matrix A, and then we multiply by the eigenvector, the initial eigenvector value given before. And then how we are going to get this is based on the previous one, 0.25 multiply by 1 plus 0.5 multiply by 1, and then plus minus 0.25 multiply by 0. Okay, so this one 0, so all these things when you add up you will get 0.75. Same goes to others value. Okay, then you will get the maximum one. Please avoid, because they put it largest absolute value, means absolute means you neglect any plus or minus sign in each value. Okay, they say here is negative, but the number, the biggest number is 2.5 here, so this is the highest number, the largest absolute value. So you get it, you get this one, and then all this value you should divide it by this number. Okay, so 0.75 divided by negative 2.5 is equal to minus 0.3. Okay, this one. Okay, so the rest is same process. Say this one 1, and then this one is minus 0.1. So you already get the current ataupun the recent eigenvector. Then use this kind of matrix eigenvector value to here. Okay, and then you again calculate until you get this one, and then you get the largest value, which is minus 7.32. So from this one minus 3.2, we have to minus minus 2.5. So from here, from the calculation here, we get the current value of the eigenvalue is 0.7, which is bigger or larger than 0.005, the error that given, the error value given in the question. So you have to proceed to iteration number 2, which is the third one, the iteration, until you get this number. Then from this number you have to identify which one. Okay class, what is the largest absolute value here from here? Okay, the answer is here. Okay, say 0.5, 3.1 and 0.49. So the largest one is here. Okay, neglect the negative signage. So and then you get this vector, the vector, and then you have to do some operation and in order to get this value. So in this case, in this iteration, actually the error is slightly bigger than 0.005, so you have to proceed until the next iteration until you get the error is less than 0.05. Until then you have to stop the iteration. So the answer is, okay, the smallest eigenvalue is given by, okay, this one, okay, 1 point ni. Okay, so you have to divide it, okay, 1 over this number. Sorry, this one, okay, the larger value. So you have 1 over lambda 4 here, lambda 4, in order to get the smallest eigenvalue, and its corresponding eigenvector is this one. Okay, that's it. Okay, enough. So we also have a solving eigenvalue and eigenvector using shift power method, but unfortunately it's not covered in our syllabus, so we just stop until this method, this topic only. Okay class, if you got any problem, any question, you might ask during our tutorial face-to-face class, which will be conducted next week. Okay, thank you very much. Assalamualaikum and good